Welcome to the critique. We're diving straight into a really technical piece today. It's an asynchronous CLI tool for archiving Gemini AI chats to Discord. And it uses both caching and a vector database for memory. Yeah, looking at this, it's clear there's some serious technical skill here. I mean, integrating ChromaDB, prompt toolkit, AI files, that's quite an undertaking, all packed into that main Gemini Discord archive async class. It's, impressive.
It definitely shows capability, but that integration itself might be where we can find some improvements. We think enhancing robustness and, simplifying things for users who maybe just want the basic archiving is key. So to boost maintainability and let users pick just the features they need, maybe think about abstracting those complex optional bits into service interfaces.
Okay, I see what you mean. Looking through the code, you spot those conditional checks, right? Like if ChromaDB available or if self.long-term memory enabled. They pop up in a few places in the main class.
Exactly. And the weakness there is having those checks scattered through the core class and its setup. It creates this sort of tight coupling. The basic job of sending messages gets tangled up with the very specific logic for, say, talking to a vector database or running a fancy input loop.
Right.
Which kind of bloats the main class. And it means even if someone doesn't want ChromaDB, they might still have to worry about its dependencies just because the logic is all mixed together. It adds friction.
But is defining interfaces and a no-op class, isn't that potentially over-engineering for what's essentially a CLI tool managing a few options? Where is that line?
That's always the question, isn't it? But I'd argue the line is crossed when it impacts testability and future changes. Mixing the core logic, sending messages, with how you initialize optional features makes unit testing much harder than it needs to be.
Okay.
So we suggest decoupling these optional parts, using something like the strategy or maybe the factory pattern. This basically moves the whole job of checking dependencies and setting things up out of the main archival class. Your core archivers shouldn't really care if it's talking to ChromaDB or just, a basic list.
Okay, so walk me through that. How would it look for a user who just wants the simple, lean version?
Well, take memory, for example. Instead of building all the memory logic into Gemini Discord Archive Async, you define a simple memory service interface. Something with, say, retrieve context function and add exchange methods. That implements those methods, but, does nothing. That's your default.
And if the user does want the advanced features, like ChromaDB,
then only if the environment variables are set and the ChromaDB package is actually installed, you'd use maybe a factory method to create a specific ChromaDB memory service instance.
Okay.
And you just inject that service into the main archiver when you create it. The core class itself doesn't change.
And the user running the simple version, they don't pull in ChromaDB or its dependencies at all? Much cleaner install?
Yeah, that makes sense.
And it would make it easier to swap things out later, like using Qdrant instead of ChromaDB or something.
Precisely. It adds flexibility.
Okay, so that architectural point leads nicely into thinking about how this dual memory system actually works in practice. The short-term cache plus the long-term vector stuff. It's obviously there to maintain context really well.
It's a solid setup, no doubt. The engineering thought is clear. However, the system could probably use a smarter way to combine that long-term and short-term context, especially to get the most relevant info within the AI's character limit. Right now, it seems focused on getting lots of context, maybe not always the most crucial context first.
I saw that part. It looks like it pulls the long-term context and the short-term context separately and then just sticks them together in the prompt.
Yeah, that's the crux of it. The potential weakness is that it just generates the two blocks and concatenates them, basically with a new line in between. Now, given you have a hard limit, maybe 8,000 characters, the default Gemini Max context chars.
Right, the model can only take so much.
Exactly. And vector searches can sometimes pull back a lot of text, right? If that long-term context takes up, say, 90% of your character budget, then the really important recent stuff, the last few turns of the conversation in the short-term memory, could get cut off.
So the AI might forget what we were just talking about.
Potentially, yeah. Simple concatenation doesn't really prioritize that immediate conversational flow.
But wait, if we prioritize, say, the last 3 messages, and that means we have to cut out a big chunk of relevant long-term context, doesn't that kind of defeat the purpose of having the vector database for depth? How do you balance that?
That's the tricky part. Absolutely. It's a trade-off. You need a more dynamic approach. So our suggestion is to bring in a dynamic context consolidation step, something that's aware of character counts, maybe token counts, and actively prioritizes the immediate conversation. The basic idea is the short-term cache ensures the conversation makes sense turn to turn, and the long-term stuff adds depth around that.
How would you formalize that, like a specific rule?
You could implement a kind of character budget. First, figure out how many characters the absolute essential recent history needs, maybe the last 3 exchanges, like you said. Reserve that space.
Okay, guarantee that goes in.
Right. Then see how much character budget is left. That's what you allocate to the long-term context. If the vector search returns too much, you have to trim it. Maybe just take the highest scoring bits or summarize until it fits the remaining space.
And you mentioned an alternative to just dumping the long-term context as one big block.
Yeah, exactly. Instead of just pasting a wall of text at the beginning of the prompt, you could try to weave it in more naturally. So rather than one big long-term context block, maybe integrate summaries or key snippets from the retrieved documents within the flow of the short-term conversation.
How would that look?
Interesting. Okay, let's switch gears a bit. Configuration. The system's pretty flexible, using environment variables for lots of settings, timeouts, API keys, memory paths like ChromoDB path.
Right, os.getEnvironment is doing a lot of heavy lifting there. And really, to make this more robust for, say, production use and just improve the developer experience, moving away from basic environment variables to a more structured, validated configuration layer would be a big win. Because relying only on os.get for potentially dozens of settings, especially when you need to manually convert types like int for timeouts or check booleans, it makes the startup logic quite brittle, doesn't it? It seems prone to errors that might not show up immediately.
Exactly. The weakness isn't just the typecasting itself. It's the lack of a central place for validation and, frankly, documentation of what's expected. If a user accidentally sets Gemini max timeout to 30 instead of 30,
It blows up later with a value error somewhere unexpected.
right, maybe hours later, and you don't want that in a tool this complex. You want it to fail fast if the setup is wrong. So the suggestion is to introduce a dedicated configuration class or maybe a module. Its only job is loading, validating, and typing all the settings right at the start, completely separate from the main application logic.
Why use something like Pydantic, though? Couldn't you just write a careful Python class to handle the conversions and checks yourself?
You could, but a library like Pydantic enforces a certain discipline and gives you a lot for free. Using a structured library like Pydantic lets you define all your settings, clearly their types, defaults, and any validation rules all in one place.
So it's self-documenting, in a way.
Pretty much. The Pydantic model is the documentation for your config. Plus, it handles the type coercion automatically, checks for required fields, and if something's wrong with the environment variables or a config file, it gives you a really clear error message right away, telling you exactly what's wrong.
Okay, that sounds incredibly useful for avoiding setup headaches. Can you give a specific example, like a Pydantic rule that would catch a common error here?
Sure. You'd have all the environment variables processed in one function, maybe call it load and validate config, which uses the Pydantic model. That model would enforce rules like Discord queue size must be an integer greater than 0.
Right.
Or if long-term memory enabled is true, then the ChromoDB path must point to an actual directory that exists and maybe is writable. Things like that.
Got it.
The central validation means the program fails immediately on startup if the config is bad, with a helpful message about the configuration instead of, running for a while and then crashing mysteriously when it finally tries to use a badly formatted variable.
That makes a lot of sense. Okay, this has been really useful, I think. A lot of good points on an already strong tool. Should we quickly summarize the main takeaways for the listener?
Yeah, sounds good. So first up was tackling that dependency friction by abstracting the optional services. Using something like the strategy or factory pattern to inject dependencies like the memory service. That leads to a leaner, more testable core.
Right. Second, rethinking the context merging. moving to an intelligent fusion approach that's character-aware, making sure the immediate conversational context isn't lost, even when pulling in large amounts of long-term memory.
Exactly. And finally, introducing that structured configuration layer. Using something like Pydantic is key for robustness, making sure all settings are validated and typed up front. It just makes the whole thing easier to manage and debug, especially as it grows.
Excellent. These are definitely actionable suggestions. We're really looking forward to seeing how these ideas might evolve the tool. Please do apply them and feel free to submit the revised version back for another look.